All right, you guys, we have about 50 minutes of a lot of things to cover in a very short period of time. So hopefully you guys are ready for kind of a fast session, and there's actually going to be moments where I need you to use your phone because I like to do things that are incredibly high risk. In other words, we're going to gamble. We're going to let you guys try some of this software out yourself. All right, so we're going to really talk about Kubernetes today. We're going to talk about serverless. We're going to talk about what it means to be serverfull versus serverless. And we're going to have some fun with Tecton, Knative. I got a little Istio in here, and we've got all kinds of things that we can show you. And it'll really depend on what works, because I'm going to show a bunch of things, and who knows what will happen. I like to do things a little bit high risk. So this is me. Hopefully you guys have run into me before. I've been to Ukraine now several times, and how many people have seen one of my sessions before today? All right, several of you, fantastic. So you might even seen some of these presentations or demonstrations, but hopefully I got something new for you. I'm pretty sure I do. At least we have some things to try in a very short period of time. I actually go out and teach classes through O'Reilly at this point, and I teach an intro to Kubernetes, and we did a fast version of that yesterday. We did a 2-hour kind of Kubernetes basics, showed people all kinds of crazy stuff in Kubernetes. And then I also teach a Knative serverless session and an Istio session for service mesh. And we're going to really kind of focus on that Knative side of things today. We're going to go more advanced today from a Kubernetes standpoint. So as a matter of fact, let's go ahead and just actually try to get a demo going real quick, okay? So let's actually see if we can have a little fun with this. I'm going to show you something right here that is kind of crazy. For one thing, I have 3 OpenShift clusters, 3 Kubernetes clusters running in 3 different public clouds. I didn't have enough time to move them all to Europe and things of that nature. If you've ever had to create your own cluster, your own cloud, it actually takes a little bit of effort to move it from region to region, depending on the cloud provider. But I'm running one in Amazon, I'm running one on Azure, and this is actually Google. Google is me, Google is Burr, and you can see it's the hub of my hub and spoke. So I have 3 different clouds running, 3 different clusters running, all with different capacities, things of that nature, but I'm running the same application across all 3. So one huge takeaway I want for you right now from this session is if you build applications the Kubernetes way, the OpenShift way, you can go to any cloud provider you want, including bringing it all on premises into your own little local data center that you might build with a bunch of old laptops if that's what you want to do, okay? So let's see if I can make this little demo run here. I'm going to go over here, and let's see, let's just put in a message. You can see it's responding from AWS, if you kind of watch closely. It's saying aloha. I typed in 3. I'll just type in 4. It's responding from AWS, and you can kind of see this little flashing thing over here. Okay? So AWS is the responder to the request because this user interface is sitting on AWS, sitting on Amazon, and therefore I want to respond with a local processor. So there's actually, it's an asynchronous kind of thing, right? So basically I'm sending a message in, and a responder is coming back. But here's what I want you guys to do. You guys get on this thing for me. Okay, so here's the URL for it, bit.ly hybrid cloud 5. I want you guys to load this little UI on your phone, and then you can push messages in as well. And then you'll see, of course, this thing animating. So it's this right here, bit.ly hybrid cloud 5. I will leave that up right here. And then again, all we're simply doing is pushing little messages. So if I say 5, if I say Burr, I say hello, I'm just pushing in messages there. So you guys can push a message in also. And I just need a couple of people to play along with me there. There's someone who did a hi, so someone got on quickly. Salam, Viva, Joseph. All right, so thanks. So we got some people playing along. You can keep trying to connect there. But here's what I really want to show you. You can kind of see we now have some messages. You can see it's telling us AWS is processing these messages. That's what this thing is doing over here. But here are these things all are. Here is my OpenShift on Amazon, my Kubernetes on Amazon. This is the one running on Azure. And this is the one running on Google, otherwise known as Burr. So that's one thing to understand right away. Because it's Kubernetes everywhere, the experience of the user, both the operations team and the developer, is the same everywhere. But what I want to do, though, is come over here to my Amazon one, and I'm going to shut down its worker, meaning its responder. I'm going to kill it. Yeah, kill the right one there. So I say stuff, okay? And notice everybody's getting messages now from Google. On your phone, you're getting a response from Google. No longer Amazon. And Google is running back in the central part of the United States. So it's actually routing from your phone through Amazon, where the user interface is, which is in Ireland, out to the United States, and back again with a response back to you. Okay? Looks like a lot of people pushing blank messages in there. All right. Why? Ping. Okay. Yeah, fantastic. Okay. But let me go shut down Google. If I take Google offline now, we're going to fail over one more. more and more, okay? We're now failing over to Azure. You see that? On your phone, you're now on Azure as well. So all your responses are coming from Azure because I killed Google. And now, so it's again routing through from your phone to Ireland where the user interface is, out to another place in the United States where I'm running the Azure data center, and again, a Kubernetes cluster there. And I'm trying to make this point because it's the same application logic deployed everywhere in a very straightforward way. In my case, I have the same user interface. And actually, let me go and bring Amazon back online. How about that? Let's go and bring Amazon back online. We'll roll that back up. All I'm doing is simply starting the pod back up. Very straightforward. Changes the replicas. I could do this through the command line if I wanted to, but I'll just use the little UI here. It'll take a second or two for those to come online. One more time. Now we see we're responding from Amazon. And then let me also do this. Let's have a little bit more fun. I'm going to come back. Where'd my little dashboard go? Right here. Okay, see that one. So we got some messages flowing there. I'm going to basically pump a bunch of messages in through this workload generator. So it's just going to basically start hammering on it really hard. And it's going to basically hammer it on from an Amazon standpoint. So once that gets going, you'll see that the message volume really cranks up. And you can see it's about 2 messages per second right now, 4 messages per second. So not a real high volume, but we'll see when my little generator starts up. 7 messages per second. So again, very low, but let's see here. Okay, we got more people putting in some crazy stuff. So we're going to have to get the SQL injection attack. I know someone's going to try that pretty soon. Okay. All right, now we're at 1,000, 2,000, 1,700, 1,800 transactions per second. So that thing is really humming along now. You'll notice also on this screen, let me go ahead and refresh it here, and you'll see this as too. You can kind of see it's basically telling us the Amazon worker is basically pumping a lot of messages. We're at 30,000 messages it's pumped through there, 39,000 messages. So it's really moving messages through the system at this point. But let's try this. So that's hitting the Amazon. And you'll notice it's mostly Amazon to Amazon. So by default, this uses a very special networking technology based on AMQP using the Apache Cupid dispatch router, another open source technology that Red Hat supports out there. And it's very clever. It's trying to use the lowest latency responder as possible. So it's going Amazon to Amazon. But what if Amazon died, okay? What if Amazon died? And this is my Amazon. Yep, I gotta make sure I'm the right one. And this is my worker. Let's kill the worker. And let's kill Amazon again and watch what happens. It'll burst out to Google and to Azure. Mostly to Burr in this case. So in other words, it's decided the Google cluster is responding faster, and most of the load is going to Burr, and a little bit to Azure. There's a little bit more to Azure right there. And if I killed Burr, you would see it fell over again. Okay? And of course, if you guys are continuing to interact with this thing, one more time, okay, you can see that it should still be online with Google responding there. Okay? In this case. All right, was that cool? Can I show you, again, application portability across all the different public cloud providers? That is kind of the power of Kubernetes. This is why if you learn Kubernetes skills, it's kind of like learning Linux skills at this point. You're now universally portable across all these players, okay? And do I need to know what people are saying here? Is it getting really awful? Okay, we'll just leave that alone. We'll come back to that in a little while. Okay, let me get back into this presentation. So let's talk about being serverless. Let's talk about being serverfull, and let's kind of jump into this. Knative, which is an add-on project over and above Kubernetes, is a technology that brought us 3 things. It brought us this thing called Build, which is now gone, and it's replaced by Tekton, so we'll talk about Tekton today. It's been replaced with this thing, it has this thing called Serving, which gives us a serverless architecture that auto-scales from nothing to something and back down to nothing. We'll see that. We'll have some fun with that. And then Knative eventing. And Knative eventing allows us to bridge the gap between HTTP and other protocols. By default, serving works with HTTP, HTTP, right? The traditional web browser-based web server protocol. And eventing basically gets you into the world of Kafka or AMQP or SQS or Google PubSub, things like that. So here's a great quote from this gentleman here who I really like. And that is, we cannot solve the problems with the same thinking we used when we created them. So if you think about it from a software development standpoint, we have been building software for so long that at this point, you will sit down at a project and you'll go, what was that original software engineer thinking? What was that architect thinking? They must have been insane. I can't believe they used that technology or that pattern or what. Look at this code. It's a crap show. Well, at that moment in time, you don't know the constraints that person was under when they had to build that particular application. And you're going to be under new constraints when you build your next application. And someone's going to come along 3 years later and call you an idiot as well. So just keep that in mind. But I like this quote because it should hopefully get some perspective here. We're going to have some fun with this. Because in the old world, when we built applications, we could build a single monolithic application. It was an ear, it was a war, it was a jar and a war and an ear, and we could deploy that on WebSphere or WebLogic, and we could deploy that every 6 months, and we knew what we were doing. But then we got a little bit more creative. We're like, well, what's in that big old application? Can we start to split it up or at least understand what's inside it? And maybe we call those modules. And we had the modular monolith, and certainly that's definitely a movement at this point in time. But then we start thinking in terms of microservices. And where this gets weird is because our application starts to fade into the background and disappear behind the microservices, which then go distributed across a network. And this is where it gets super weird. It's now distributed. There's now a network connection amongst our components. And as you might know, the network is never perfect. It's certainly not perfect right now. It wasn't even perfect in the little demonstration we just ran with your phone. Things fail, packets fail, right? Especially if you're bouncing around the globe like we just were. You also have to have your own databases in a microservices world. So you used to have one single big old Oracle database or one big old DB2 or one big old SQL server, and now we're telling you, well, use a Mongo for that one, and Postgres for that one, and MySQL for that one over there. Or, Redis or something else, Cassandra, whatever you might want. And that's getting weirder still. Okay? Then there's multiple points of entry. We used to have one single portal where everybody could talk to the application through one user interface that we created. And now we have this API layer, and we have to have some form of API governance or API gateway technology so people can access our endpoints in the proper way, making sure they're properly secured, we know who should be accessing what. And of course, we have many teams now with all their individualized pipelines dropping these microservices into our deployment environment. But this is where it gets kind of weird, okay? So here's another great quote from this fellow. Change is the essential process of all existence. So all that stuff I just talked about real fast is stuff we already know how to do, right? We're already mastered those techniques. Well, not really, but it's going to get stranger still. Because now, instead of microservices, can we do serverless functions as part of the logic associated with this application, involved in those transactions? And then, of course, if you look at it from this perspective, we now have to live in this new world where every hour, every day, every week, a pipeline and a team is delivering a new component into the production runtime, and it's happening constantly, versus the old world we lived in, which was we deployed every 6 months with our monolithic application. We deployed it consistently, and we were good at it. Every 3 months, we could do it like clockwork. Now we're asking you to do it like every day, every hour, every moment. Okay? So serverless, how does that enter into this equation? Serverless versus microservices. Now, serverless has actually been a thing for quite some time. You'll see right here, we have a situation where serverless was coined back in 2012. Actually, it was coined by the person from Iron.io. Iron.io and Firebase, back in 2011, were giving us database in the sky, database in the cloud, and messaging in the cloud. So in other words, we had these existing cloud-based services that were serverless because as a software user, software developer, you treated it as a software as a service. You did not actually you didn't actually provision servers. You didn't provision virtual machines. You ignored all that. You simply said, here's my application logic. Please run it at scale for me. Or in this case, a database entry or a messaging queue or message in that thing. So Iron.io and Firebase and serverless kind of started a long time ago. But then Amazon Lambda happened right here, right in 2014. You can see that. And that's where things got really turned upside down. When Amazon Lambda came out, and they actually showed the world that, by the way, you know that $225 you spend per month to run a bunch of virtual machines? On Amazon Lambda, the same application runs for 8 cents a month. I was actually at the event where they actually displayed these numbers to the audience to basically tell you what Amazon Lambda was all about, and people really lost their mind, right? $200-something to 8 cents sounds like a nice savings. But more importantly, you don't think about the infrastructure. You don't update the VMs. You don't have to worry about the underlying operating system, et cetera, et cetera. But things have really picked up steam. There's been a ton of things happening within the serverless ecosystem since that point, and we're going to talk about some of those things and show you one in particular. But there's one pattern I want you to be aware of when it comes to thinking about serverless architecture versus microservices architecture. Is there a service you can consume and not have to rebuild? Now, I know many people who are Java developers, and I bet there's someone in this room right now who decided, you know what, I'm a Java developer, I can write my own message broker. And you might have tried. I know there's definitely people in this room who tried to write their own caching system. And despite the fact that there are great ones in open source, you decided to build your own. Maybe you work on a project where you built your own MVC, Model View Controller framework, and didn't decide you didn't need struts or Spring or anything like that. So this is what we do in the Java ecosystem. We rewrite stuff even though it's already out there in open source. You know, our own object relational mapping software was another good example. People might do that instead of using Hibernate. So just think about that, because in a serverless world, you try to consume before you create, okay? So it's serverless because of BAS, backend as a service, and software as a service primarily. So it's all about the services. So in other words, don't build an API gateway. You can easily take a Nginx, or you can take a HA proxy, and you can basically use Lua, right? Lua code. I was just in Russia a couple days ago, and these folks are telling me, okay, we write all this Lua code to basically build a really nice API gateway on Nginx. You could do that. All right, but you don't have to do that. You're right. Well, how about an SSO is another good example. You could basically create your own OAuth authentication system, things of that nature, if you wanted to. It's a pain in the butt, but you could. Or you could simply use Keycloak, a free open source project that gives you all that stuff out of the box, and you just simply run it. Or you could simply use another one of the hosted providers as another example. Or how about storage as a service? Do you want to actually have a globally distributed storage system? Or would you just use S3, like most other people do, to basically have your PDFs and images and sound files cached across the globe, as an example? Or maybe cache as a service, or database as a service, or messaging as a service. So messaging in this case at the top is the messaging that is referred to as, you know, your pub sub type messaging, where you have like JMS, if you remember that old school technology, or AMQP, or Kafka as a service, as an example. And then notifications, where you might have push notifications going to a mobile device. So all these are possible in this new world. This is what you should be thinking about. Is there stuff that I can just consume, and then I start building my microservices? I start adding my services beside those services. I don't want to rebuild the caching service. I will build my application to use the caching service, but you might still have microservice there. And then you might have connective tissue, which are your serverless functions, okay? So that's what I'm going to try to show you, is the serverless function concept here as we go. But that gives you your event-driven input, your event-driven output to your application. And of course, if you do all this correctly, your end users have a nice experience, and you're saving money. And more importantly, you have a vastly more dynamic architecture. In other words, it's less brittle, might be more likely to break in some cases based on how you connected these dots. But you now have the ability to change things very easily, and that's kind of the point. So in a microservices world, you just have to remember that you had the control of the microservice. You actually wrote code in a microservice that was no different than you did when you wrote a monolithic application. You actually used Spring MVC, Spring Web, and got a REST endpoint, or used JAX-RS and JPA and got a REST endpoint, or used some other of the dozen other frameworks we have in the Java community to build a REST endpoint. And even if it was a monolith just 5 years ago, you could copy and paste that into a microservices framework like Dropwizard or Vertex or Spring Boot or something else for that nature. Maybe now, if you look at our Quarkus technology that we've been speaking about here at the conference, right, a really fast runtime for Java programmers, you can build that microservice very easily. The programming model is the same between monoliths and microservices, basically. The only distinction is how you distribute things and where do you add your circuit breakers and resiliency and things of that nature. But the code looks identical. You have a long-lived process on the microservice side. So in other words, you expect the JVM to be up for maybe a day, maybe a week, maybe a month. And as a matter of fact, we as software developers used to take great pride in the fact that that system we built running on WebSphere, WebLogic, or JBoss will run for months without a reboot. That's a long-lived process. Microservices still believe in long-lived processes. So you have to keep that in mind. The service stays up. In a serverless world, it comes up and goes down, goes up and down, sometimes within about a 2-minute window. As a matter of fact, with Knative, it's a 90-second timeout. So by default, within 90 seconds, it turns itself off if no one else is using it, as an example. Known programming model on the microservices side, a traditional sync request response model. So everything you used to do in microservices and everything you used to do in monoliths is kind of basically the same. So no big deal there. But on the serverless side, right, we have a different programming model. We have a different control vector. In other words, we're no longer in control of the process lifecycle. The cloud vendor is. They decide when things start or stop. And it's more event-driven and asynchronous. So serverless is different from the world we used to live in, especially if you use a specific one from a specific cloud provider. Now, here's the thing that you're going to hear in this presentation, what you're going to see that makes this a little bit strange. In the world of Knative, it actually blends the model. It can make your microservice serverless, okay? So kind of put that in the back of your mind for a second. We'll see this in a moment. But it can actually take your microservice and make it serverless, dynamically auto-scale up and down, okay? So let's talk about function as a service for a moment, FAS. There are many FAS players in the Kubernetes ecosystem, and this is where it got pretty weird. For the last couple of years, we had all these different function as a service providers showing us different capabilities running on top of a Kubernetes cluster. And there were a lot of them, and there still are a lot of them, like IBM's OpenWhisk, or the FN project from Oracle, or the Rift project from the Pivotal team, the Spring team, as an example. OpenFAS is still probably the most popular one in the space between OpenWhisk and OpenFAS. So those are still very popular. But just keep in mind that these things also created a little bit of chaos for us. So Knative was born just recently, and I say recently, in July 2018. It was announced at the Google event. And it came about because the ecosystem needed to have some constraints, let's say. Everybody was reinventing the wheel across all these different open source projects. They were all extending Kubernetes in these very interesting, clever ways. And so the question was, could you basically take some of that and consolidate it into a single open source project? So if you see here, you have now the concept of Knative giving you the capabilities of, well, how do you build an image? How do you invoke a resource? How do you auto-scale? How do you do event binding to non-HTTP? What about observability? What about routing? So in other words, Knative took a lot of those things that everybody was doing, building images, routing, auto-scaling, and tried to pull it into a lower layer. And this gives the opportunity for the people at the FAS providers to then build developer experience on top, a function API programming model if they want, additional event sources, and of course, how to build tools and things like that. So this is kind of sort of occurring in the ecosystem. I would say it's actually not played out as well as we had hoped when we kind of invented all this technology back in the day, meaning a lot of the FAS players are really still doing a lot of their own things and kind of ignoring Knative to some degree. But at this point, Knative is a thing. If you actually saw the presentation earlier by the Google folks, right, they actually have it as Cloud Run. They're running on the Google Cloud. We're running it at Red Hat as part of OpenShift Serverless, and as part of our supported technology that we offer customers as well. So we have a number of players that are supporting the Knative project at this point in time. And of course, Kubernetes is still everything where everything runs. It's still a deployment, a replica set, a pod, a service. All those things still apply, and we're going to see those as we get into this. Okay? So Knative gives you the base primitives. It gives you the core components, the key capabilities. Think of them as middleware components that connect your application together and give you some of these special features. Okay? Scale to zero, scale from zero. That's primarily what people get excited about. So if something is not being used, if the pod is not being used, drop it to zero. Give the memory back, give the CPU back to the cluster, and let another job run. So if you have spiky workloads in your application architecture, this could be for you. All right, this is where you might think of taking advantage of this technology. Spiky workload, a good example. Some of you work for financial services organizations, banking, transactions, trading, things of that nature. Well, guess what? You tend to spike Monday morning at the start of business, whatever that is in your time zone. Typically, it's 9 o'clock in the morning. That's when all the traders, bankers, whatever, show up, log in, and start reviewing their transactions. They don't do that on Saturday night at 2 a.m. They don't do that on Friday at 5 p.m. because they're out of the pub already. So if you have spiky workloads where all the nurses show up at this time, or whenever they change the rotation, or all the teachers show up at this time, or basically all our business-to-consumer users, like all our e-commerce users, seem to show up on Black Friday or another day of the week based on some big sale we just ran, or there's a big marketing event that's going to drive a ton of people into the system right now. That's a spike in the workload, a spike in the load, and then the question would be, do you need to keep scaled out for all that all the time? And with this, the answer is no. Scale it all down and let the big Hadoop job take advantage of those CPUs and memory. Let the big, TensorFlow job, if you ever run TensorFlow, it uses a ton of resources. Give those resources to TensorFlow so it can use them now and do its calculations of, coming up with a new model. So just keep all that in mind, all right? So we'll get into this. Knative serving. So one thing, it's based on the concept of a CRD, custom resource definition. Everything that extends Kubernetes now is based on custom resource definitions, CRDs, custom controllers, and operators. So we'll kind of just go ahead and show you some of this stuff. Let's get into this thing here a little bit. So when I say operators, I mean these things out here at Operator Hub.io as an example. These are extensions to the Kubernetes ecosystem. And we're not going to spend much time here with any of these because I've already got them installed. But you would install these things, and let's say you say kube control get CRDs, And this, you can see that on this cluster, I have a lot. I have a lot of CRDs which extend the schema and API. And if I say, let's go grep for the Knative ones, okay, let me get just the Knative ones as an example. I can see here I have serverless services. This is actually the primary thing you interact with, is this thing called services, which give you the serverless services. But you can see they have pod autoscalers, revisions, routes, things like that. But the whole ecosystem now works this way. So if I look for my Istio as an example, which is a service mesh technology, you can see there's virtual services, things like Stackdriver, stats, all kinds of good stuff there. Even on this cluster, I think I have Kafkas as well. So we have Kafka as an object. So if you want to deploy Kafka brokers, all you have to do is say declaratively, give me a Kafka broker, and Kafka brokers start springing to life. This is the beauty of the Kubernetes architecture. You have a declared desire for what you want. I want a serverless service, I want a service mesh virtual service, or I want a Kafka, and it magically springs to life, right? That is kind of the real awesomeness of Kubernetes at this point. And you would just have to keep extending it. Here's my Minikube over here. You can see I just started Minikube. So in a brand new naked Minikube, if I say get CRDs, there are no resources found. Because in a naked Minikube, it's just bare bones, traditional object types, which let me see if I remember the command here, kubectl, API resources. Let's see here. You'll see the bare bones object types, which are built into every Kubernetes cluster, like deployments, replica sets, pods, things of that nature. Okay, so these are the bare bones objects, the things come out of the box with every cluster, and then you have the CRDs, which add new object types on top. So let's kind of get back into this, and we'll show you some more of these things here. We'll show you your first serverless service here in a moment, okay, before we run out of time. Now, if you work with Kubernetes, you work with these objects right here. You work with a deployment, a replica set, and that creates your pods, and then you have a service, which basically talks to those pods. So this is what you do as a developer, as a user. You say, here's my deployment, and a replica set is born, and a set of pods are born. So let's hack on this a little bit and see if we can have a little fun here. Let's see here. I'm going to come over here and hit clear. Come on, type Burr, type. Let's see here. And let's just go to this Quarkus one, cube files, and ignore the fact that I got a bunch of files here, because I like to show that you can actually deploy the same thing in multiple different ways. So if I look at my deployment here, let's actually just bring it up and show it real fast. You're going to create a deployment YAML normally. There's lots of ways to do this, but you're going to create something like this. It's a deployment YAML. You can see it says corked Burr. I want one replica. We want this image, and that's the key part. This is the image it's going to pull when it actually says run this on the cluster. And so if I come over here now and say kube control create -f or apply -f, which is more correct, but not in all cases, so I just say create. I'm going to create that document. That document goes to the API, gets into etcd, and of course, that document hits the system, and so I have now a deployment in the system. See, the deployment, and I have a bad image. You couldn't pull the image, but I have a deployment in the system. I have a replica set, okay, a replica set, and I have pods that are almost coming to life. Let's see. We can maybe go mess with that some more. So, yeah, that one should have pulled. I've pulled this one before, so it might actually be having trouble getting out to the actual image at this point, out at Quay.io. But you can kind of see right there, that's what it's doing. And actually, let's hack on it a little bit. Maybe I did something to that image. It's certainly possible. So deployment. This is what was that deployment called? Corked. Edit deployment corked. I think I did that right. Yeah. Let's see here. Okay. Oh, no wonder. I deployed the wrong file. That's part of the problem. This is looking for the local image in my local registry, which I don't have it. So let's just switch it up here. Go to Docker.io instead. And let's see if that can pull that image. Let's see if that solves the problem. Okay, so notice it's killing the old pod that was having trouble, and a new pod should be coming out. It's doing its little rolling update thing, and if it can find that image, it'll bring the pod to life. We'll give it another second or two to see if it comes out. There we go, almost. See, it's 0, 1, and 1. All right, we're good now. So if I come over here and say kube, control, exec, IT, let's just hop into that image. All right, sorry, pod in this case. The image has been pulled, but now we're going to hop into the pod. And let's see. Okay, curl localhost 8080. And you can see it just says aloha corked. That's what it does. And it kind of gives you the pod identifier right there, right? So it's a very simple little application, a little hello world, but this is traditional Kubernetes, nothing fancy so far. And if I want to get rid of it, I say kubectl, get deployment, right? This is the deployment, the object that governs everything, so let's delete it. If we delete the deployment, corked, we'll see everything else go away. The pod goes away, the replica set goes away, everything gets shut down. You can see it's terminating right now. Okay, so that's your traditional Kubernetes, and that's your intro to Kubernetes if you've not had one before. Now, here's where it gets interesting with Knative. You still have the deployment, the replica set, and the pod, but now you have a revision, a configuration, a Knative service over and above that. And you actually have all this other infrastructure as well. So you have all these other capabilities that are required to do that dynamic burst auto scale up and down. So when you create a Knative service, it gets a lot trickier. Oh, by the way, I should mention the slide deck is at bit.ly serverless cube. You don't have to take photos of all the slides. You can just go to that bit.ly link and get access to the slide deck in source form. And it's just a Google Doc, so you can just basically say file and make a copy of, with your Google login, and you'll have a copy. But let's come back to this now. Let's look at this thing. So I have, again, get CRDs, grep, Knative. Remember, we have these custom resource definitions. And you can see we have this special services here and serverless services here. And if I say kubectl get ksvc, Knative service, I have none. I have none deployed right now. But let's go ahead and deploy one. But let's do this a little slowly so we can kind of see how this works. Yeah, let's see here. Watch kubectl get all. And we're going to make some magic happen here if things go for me correctly. And you can see it's actually rather slow because in this case, this cluster is running back in the United States. I should have moved this particular one to Europe, and it would be a little bit faster. So it's a little slow when it comes to responding to it. Because with the kube control, you're just basically doing interactive, right, API calls. This is a REST API call, just like any other API call. Notice this little internal cluster ingress. Ignore that for now. That's just something Knative puts there to help part of its infrastructure. But let me go into this little Node.js application. Okay, so let's take a little Node.js, and then let's look at the kn service deployment file. Notice it's a little bit different than a deployment. Okay, one, it's got the API version of serving. It's got a kind service, because it's a Knative service. See, it's a Knative service. And it has things like auto-scaling targets, and it still has an image name. That's the most important thing. It also has resources and liveness and readiness probes, like a regular deployment does. So those are still important. You still want to make sure you have the right constraints for the memory and CPU. You still want to have the right setup for your readiness, health, and well-being. But let's actually see if we can deploy this thing. So we're going to say kube control create -f, and this is in my kube files, and this is kn service _ docker, because I'm pulling it from Docker. And let's see if we can watch what happens here. So we're not using a deployment replica set pod, but we're going to get all those artifacts as this thing goes to deploy. So it's trying to deploy the pod here, but there's actually a bunch of other things that are currently happening. There we go. You can kind of see, look what happened. So there's the pod running up there, but then I have 3 different services. I have this deployment, I have a replica set, and actually, because I'm scrolled off the screen here, let's actually make this a little bit where you can see more of it. There's all the other infrastructure components of the Knative service. So this is a bit of the magic you should be aware of, because there's a lot of other things that have been put in place. Come on, kube control, get done here. Got to get you finished. Oh, it seems to be taking some time. I should have moved this cluster. But here you go. See, there's the revision, the configuration, the route, all those things that I mentioned earlier right here, okay? They've now all started to happen for me. So this infrastructure is now in place. And if we actually just take a few more moments, right, this is my pod running right here. This is my application. It's running right now. And if I'm quick enough, let me see if I can be fast enough. Exec into it like we did earlier. I think this one has bash. And let's see here. Come on. Will it be fast? Localhost 8080. Okay, see, it's just like my other little application. And it looks kind of normal. Okay, we did create this thing called a case service. Let's get here, case service. And there, see this case service? And we'll just give it a little bit longer. It takes around 110, 120 seconds normally. And basically, Knative realizes no one's using this thing. Let's shut it down. Okay, so we'll give that a few more seconds. We'll see if it'll actually start shutting down. but we don't have to wait for it. Let's actually crank up a few more things here. Let's add a few more services. kubectl create -f, kube files, kn service. Let's get this Java-based application up and running. Okay, so Java-based application. Let me go do, let's go do this other one. Actually, let's do, so there it's killing the Node.js, but the Quarkus one's coming online. Let's just bring up the Python one, kubectl create -f. All these little things work basically the same way. Okay, it's just pulling different images. We're going to bring up the Python one also. And if we are careful, you're going to see all these things coming to life at this point, right? All these things are now coming to life. You can see I have different deployments, Node.js, Python, Quarkus. But watch this right here. They're ready. All right, update, up to date, available. Because Node.js is not being used, it's at 0 of 0. It's all the memory is gone, all the CPU is gone. It is not in existence anymore in the system. The deployment artifact is still here, but it's at 0 of 0. And the trick is, when we hit it with load, it comes back to life, okay? So there's our, you notice also, by the way, when I first deploy my Knative service, it actually builds a pod as if you want to see everything. It assumes you want a pod to come to life. So by default, when you deploy it, it brings one to life. But after about 90 seconds to 120 seconds, it starts to shut it down if no one's using it. Okay, that's the default behavior. But let's do this real fast. Let's see here. kubectl get kservice. Come on. Let me grab this URL, and if I'm fast enough before someone in the audience types that in, I can come over here and bring this guy back to life. So watch closely. Let's go, just bring up another little window here. Move this off to the side, and paste that in. And so I just basically hit that URL. Notice the Node.js is coming to life. Notice the 0 of 1 right here, if you look closely, because it's now saying, hey, deployment, oh my God, load's coming in, get one started. Okay, I'm trying to start. It's got to pass this liveness probe, it's got to pass this readiness probe. And as soon as it goes 2 of 2, because there's a sidecar here, and you see 1 of 1 here, your user will get a response. Because in a serverless world, this is known as the cold start latency. I had nothing running for that specific resource, and at some point, we have to wait. The first user has to wait. Now, you can actually solve that problem. This is a problem for a lot of people. With Knative, you can actually fine-tune all these parameters. You want it to take a little bit longer before it auto-scales down, you can set that variable. You want to change the concurrency factor, because by default, in a serverless architecture, the concurrency is typically 1 event, 1 pod. 1 event, 1 container, right? 1 thing to wake up. But you can actually change that number, and by default, it's 100 out of the box with Knative. Also, you notice it's buffering the request. The request that's coming in is being held until we can get the infrastructure stood up to respond to it, okay? And you can see my Python is now going away. My Quarkus is now going away. So let's try one more thing. Kn burst, okay. Let's actually hit the Quarkus app with a little bit of load. And at the same time, I'm going to just go ahead and bring up my, keep my pod for Node.js alive. But look right here. I hit the Quarkus app with enough load that it panics and it says, oh crap, I got to start 4 of these things. There's so much load coming in. As a matter of fact, I sent in 40 concurrent users, 40 concurrent requests, and therefore it's like start 4 pods, 4 application servers, 4 microservices to deal with that. Now the part that's kind of really neat about this, you can see here's my Node.js running. Let's actually keep the Quarkus one running. Okay, my Python one is terminating because no one's talking to Python. It's feeling bad and no one's talking to it. But let's come back over here. Okay. Let's look this up in Visual Studio Code again. And this is just my stuff I hacked together, right? So I'm not a Node.js programmer, but if you look here, it's just a little simple Node.js. No difference between this and using Express and a microservice and Node.js, okay? If you look at my Quarkus application and look at the Java code for that, it is just a simple JAX-RS endpoint at path, at get, no big deal there. Standard programming model, okay, as you would in a microservice. If I look at my Spring Boot application, okay, let's go to my Spring Boot application, and let's see here. Standard REST controller, get mapping. The code is the same, but you get this dynamic auto-scale up and auto-scale down. You get the serverless capability, but the same programming model when you use Knative, okay? So that's one thing to keep in mind, that the way it works is very clever. And also notice, by the way, you see my Quarkus are now terminating? And that's because Knative says, well, you're not really hitting me hard anymore. Let me downscale. Let's pull it back, okay? I don't need all those resources. Let's give the memory back to the cluster. Let's give the CPU back to the cluster. Let Hadoop take it or someone else take it at this point. Now, I want to show you one more thing about this, and then we're gonna have to switch gears here to the next topic, because I got a lot of other cool things to show you. Let's see here. Was it, where'd it go? No, that one, this one. Not that one. Oh, wrong one, this one. No, what was I gonna show you? Oh, yes, I was gonna go here and show you this. Let's see. Okay, this is a little hard to see, but let's see if we can check this out. What do we have? This is my Node.js application. Come on. You can kind of see it right there, 27 megabytes for my Node.js application that's auto-scaling up and down. So if I want that 27 megabytes back and no one's using it, it'll downscale to 0, and you get the memory back. My Java-based application is this one right here at 16 megs of RAM. This is because with Quarkus, if you saw the presentation yesterday, we can compile it to a native executable and make it insanely small, insanely fast. Okay? So just keep that in mind. If I come over here and launch my Spring Boot application, kubectl, a regular JVM-based application, create-f, kube files, kn service docker. We'll load that from Docker. It takes about 100 megs of RAM, and it takes a little while to get started, so we'll see. We won't wait around for Spring Boot to get started, but that's the same basic concept. And actually, we'll just leave the polar. No, the polar won't work. We'll just let that run in the background. But again, the concept here of having an incredibly lightweight footprint is important because it starts faster. When it dynamically auto-scales, it matters that how fast you start and how much memory you use, because you're paying for this memory and you're paying for the CPU to your cloud provider. That's what I'm doing right now. I'm paying these cloud providers as an example. Okay, let's get back into this thing and talk to you some more about, we did that demo. Let's talk to you a little bit about Knative eventing, and then I want to show you some cool Knative eventing. And that is another CRD. You can look for eventing, and it has this concept of subscriptions, input sources, and that's the two things you primarily care about: channels, subscriptions, and input sources. By default, there's a cron job source, meaning launch this Knative service every hour, every minute, every day, whatever it is. Think of it as a batch job. So it's not running by default, and then basically the cron job says make it run. Spin it up, make it run as an example. And so Knative eventing allows you to bridge the gap between HTTP and other types of inputs, okay? And so here's the different types of inputs. There's a GitHub one, there's a WebSockets one, an AWS SQS one, there's a PubSub one from GCP, and then Red Hat has been working on the Kafka one and the Camel one. And the Camel one is very interesting because it bridges to the rest of the world. And we're going to have a lot of fun with that one over time. It still needs to mature a little bit more, but it actually talks to any protocol, whatever you can think of, right? We're going to do FTP and SNMP and all kinds of stuff like that. But the one I want to show you right now is this Kafka one, because this is one that I'm as a favorite of mine. And then, so if you think about it, what I showed you earlier, well, yeah, let's come over here. No, let's live over here for a little while longer. I can live in this window. We don't have to mess with those things over there, okay? But let's do this. kubectl, kube control, get CRDs, right? I showed you this earlier. There's a Kafka object in this cluster. And so what this means is I can spin up Kafka objects. And I showed this yesterday. I'll just show it again real fast just so people can see it. All I have to do is use a declaration for my Kafka, and I just have one here on GitHub where I mess around. And let's see if I can go find it real fast. And it's the kube files. And it's just a YAML file like everything else in this world. So let's see here. It says Devoxx cluster. That's what I named it yesterday. Let me get raw. And so right there, kind Kafka. See that? This is how it works, right? This is the way all these CRDs and operators work. So create-f, paste that URL in, and we'll just let this run right here. This is actually kind of funny. It's going to start my Kafka brokers, though, inside my right beside my little serverless services. And so there, you see right there, there's my 3 zookeepers coming to life. So by default, it's set up for production of Kafka, right? You have to have 3 zookeepers, 3 Kafka brokers, and now that thing is coming to life, okay? But what I want is Kafka to be an input source to my actual service, my Knative service. So just to kind of show you this, before I run out of time here, because there's one more thing I want to show you. Let's see, we're going to come back over here, go here, and this is running, is this running on on Azure? I forget where it's running. Let's find out. Oh boy, echo, Where's this one running? Cube config. There we go. This is on Azure. This is my Azure infrastructure. So let's go here to Azure. Let's go here. Yep, this guy's running. So notice this guy has no pods running right now. No pods of that guy. This is the sink side of Knative eventing. So you have a source, input source, and you have a sink. Where does all the data go when the data comes flooding in? But right now, there's nobody talking to my cluster except for me. And let's actually hit it real hard. So I'm going to basically put a watch on this guy so we can see there's no pods running right now. Let me do a stern for logging of the, this is my Knative sync. Okay, well, there should be no logging at this point in time, but I can produce a lot of messages. Let's go and crank it up to 11. I'm going to flood it now with 1,000 active transactions, and I purposely set this to basically scale harshly, if you will, right? So already, because there's 1,000 requests it's never seen before, 1,000 users showed up and hit the button at the same time. They put something in their shopping cart, they all logged in, they're starting to do their trades, whatever it is their users are doing, and it's scaling as fast as it can. Already it's trying to get, it has 3 up, but it's trying to get 30 more up. Okay, so the algorithm that Knative uses is actually sensitive to the volume of load as well as to how you basically constrain it. Now it's trying to get 60 pods up. It's trying to get all these things up as fast as it possibly can. If I come over here and watch this, you can see where it says pending? That's pending says the scheduler is trying to find a place in the cluster to run it. Okay, but when it gets to running, of course, it's a running thing. Now it basically says, wow, the load was so overwhelming. Let me get to 122 pods. It's now thinking it needs to get to just to handle the load. 21 are up, and it's dynamically auto-scaling in the face of that dramatic load. And you can kind of see, again, how important it is to be fast and small and lightweight. But this is the nature of serverless, Knative serving, Knative eventing, and what I used was Knative eventing, the Kafka event source, to basically say, scale a service as fast as you can. And so you can kind of see it right here. Give it a few more seconds. It should get up to 122 pods. And here's what's funny about this. It's scaling, launching these processes across my cluster. This cluster, by the way, has a lot of nodes in it. If I say, okay, kubectl get nodes. Okay, there's a bunch of nodes in this cluster. Several of them. Oh, actually, there's 2. This is one with only 2 nodes. But they're like 32 core machines. They're pretty big machines. And see, it's almost going to get there. But here's what I want you to see, though. As soon as it gets there, it realizes, well, hey, I don't actually need all that. And it starts dropping them dramatically, down to 22, 18. Because no one's actually loading on this system. Now, if you guys jumped on my system, it's a public cluster. You guys could drive load in, and it would start scaling back up. But in this case, I'd stop putting load in it. So Knative is trying to be very clever about the burst in traffic and trying to get the infrastructure stood up based on that load. Okay? Now, let's show you one more thing and have a little bit more fun, and then we have to finish up because I'm running out of time. All right, so that's Knative eventing in a nutshell. Knative build became this thing called Tekton. Tekton it became such an important project or sub-project that it was given its own foundation and given its own project. It's called Tekton now. And this is where you create pipelines, tasks, steps, and pipelines in the Kubernetes infrastructure, and it's how you build the image that you then deploy. So already what you saw me doing was use an existing image, but how do I get an image to begin with? So Tekton is governed by this organization, the CD Foundation, and that's actually is their domain name. They have a very clever domain name, Continuous Delivery Foundation, and contributions from Google and CloudBees, IBM, Piltover, Red Hat, many more. It originated as a Knative build project. It is basically the ability to build an image in your cluster and then automate deployment from it. It has a bunch of new CRDs, right, pipelines and tasks, and then you get reusable tasks out of the box, like a git clone is out of the box. You don't have to do a git clone. You can figure that out. You might have a Maven build or Docker build. There's lots of different solutions here. But the way it works is the pipeline has the concept of a pipeline resource, a git clone thing. It has to get something from a source code repository. It has a task. A task has a step, or maybe multiple steps. This is a pod, by the way, and these are containers within the pod. And then you're going to simply chain those together, produce an image, and then probably another task, which does your deployment to your cluster. And it looks like this, right? The pipeline has tasks. Tasks have steps. These tasks are pods. Steps are containers. So let's see if we can actually hurry up real quick and try one of these things while we have a few more moments. So let me bring up the code for this one. And you can see I already have 2 running, blue and green. let's change this up real quick. Let's deploy my canary deployment. All right. Oh, and we don't want to say bonjour. I did this earlier. Let me go find it. Here we go. Is that, you guys will have to tell me this is correct or not. Look like hello in Ukrainian. I don't know. I might be completely wrong, but we'll give it a try. We'll have that. So git status. We saved our code. And good. So git commit. Oh, come on. And then so updated. Just really bad message there. Push. We're going to git push it up to my GitHub repo. And so there we go. And let me just go and start my pipeline. You can actually make the pipeline start automatically. I'm doing it purposely on manually because that way we can see it better. So watch what happens now. The pipeline is another object type within Kubernetes. And it's basically saying, well, I have to have a pod to run the pipeline. And you see there's a pod coming up right now. I'm going to do some logging. And the reason it's actually taking a little time at this moment is because it's actually starting a volume over here on Amazon. So if you look carefully, you'll see there's a volume being created because it needs a scratch disk between all these steps. I do git clone, I do a Maven build, I do a Docker build, I do this, I do that, et cetera, et cetera. It has to have a shared piece of disk for that. So this disk actually just got started over here, okay, November 2nd. Okay, so that disk was just launched because this is running on Amazon. And there it goes. It's doing its git clone. It's doing its build, all right? You can kind of see. I also have some logs in there. You can see what's going on there. And look at this guy right here. Let's actually come over here and say list containers. Look at all these containers inside that pod, okay? You can see it basically creates the scratch disk. It does the git clone. I have these steps in here for listing the sources, echo the source, cat the source. What is my image? Build sources is Maven build. You can see it doing its Maven build right now, Maven package. And then I list that out to see that the target was created. And then, of course, we do the build image. And in the case of Tekton, it doesn't use Docker build because Docker build is meant to run on a Mac, meant to run on a Windows machine. This uses Builda or Kaneko, which is meant to run at scale in a cluster. All right, no daemon required, no root access required, and you want to run them at scale in a cluster. So you're going to see that process is going through that. And then the last little bit, though, if you guys will have a little fun with me, let me go back, pull this back up. Go to this URL for me. We'll let that finish. And that's going to bring up this UI here. Okay, you're going to get a little user interface like this one. And actually, let me roll it up here too. So, and you'll notice you're getting the blue pods only. You'll see the pod identifier there, the blue pod. It says hello. Green actually says bonjour. And if I bring it up over here, okay, it's building the image now. You can see my pipeline running in the background there. Okay, so basically I have a blue deployment running right now in a blue-green sense. If I want to switch it, I can switch it to green. And let's switch everybody over to green, and then it should include you and the audience. So green, green, green. Anyone else get green? I see some greens out there. Okay, so that's a blue-green deployment, and this is using a feature called Istio, and that's really what I want to kind of show you. It's kind of a little bit more fun and exciting. Let me switch everybody back to blue, because that's the beauty of a blue-green deployment. It's like, oh, crap, I didn't mean it to go green. I don't want it to say French words. I want to roll that back, so we make it all blue, okay? Or when we switch it back to green, okay, it's a lot of fun. And this is actually a simple little application. It's just polling the server and getting a message back from the server to say what version of the code you have running. So there I made it all green again. But if this guy would finish, what I want to show you is some clever canary deployment that we have. Okay, it's probably going to take a few more seconds longer. It's almost done. But you'll see my canary deployment roll out, my canary pods. And then you can be very selective about who sees the canary deployment. I want only iOS users to see it, only Android users to see it, only Firefox users to see it, and that's why it's a canary deployment as an example. So it's doing the push right now. So if you're familiar with Docker push, it's doing the push into the local registry after it's built the image. This is actually one of the longer steps, so hopefully it goes a little faster. But you can kind of see it did the Maven build. If you're familiar with Maven, it did all the Maven build with all the downloading the internet already. It did cache it in a local Nexus mirror running in my cluster. There we go. Almost done. Okay. And what you'll see is a second pod show up, and this pod is responsible for deployment. That's another task with a set of steps. It's responsible for deployment. And once it gets its job done, you will see, again, 2 canary pods show up here. And let's see. Come on. Almost. Get done. There it goes. And then we should see our canary pods show up, or start showing up. There they are, they're coming to life. Notice though, you're still on green. You're not seeing the canary, because the canary is a canary deployment. You're not supposed to see it. Oh, I am out of time, aren't I? All right, so one more second. I wanted you guys to see this thing, so all right, they're almost ready, my canaries. Almost. I need to go 2 of 2. The 2 is the sidecar there. And, but let's actually show you what this looks like. Yep, we're ready now. But I have these Istio rules. So let's say I want to deploy to only Android. Let's do that. kubectl replace -f. Let's see here. This is the source. Where did I put this file? Source Istio. Oh, so source main Istio. No, not that. Okay, that might have just messed it up. I don't want to replace all those things. Green canary and Android. Let's see, will that work? Where'd that work? And where's my Android? Nope, that's my iPhone. Android, there it is. Android gets the yellow one, and of course, the Ukrainian hello. So you can do the same with all the other browser types, whatever it might be. But I want to show you that last little bit, because that's really where the power pipelines come in, and of course, something like an Istio service mesh technology. There's a lot of resources available to you. If you want my demonstrations, they're all here listed, and again, with this slide deck, with this link, bit.ly serverless cube, and you have access to the Knative tutorial, which walks you through the same things you just saw today, my side-by-side example where I ran Node.js with Spring Boot, with Quarkus, with my Knative example, the same one you saw there with Kafka, the blue-green deployment model, and then there's the other intro Kubernetes, Istio tutorial, and a Quarkus tutorial for you to take advantage of. And that is all I have time for. Thank you so much.
Sutter, thank you very much.